It's still day 17 of Leetcode 75. We're doing determine if two strings are close. So this is 1657. Two strings are considered close if you can attain one from the other using one of the following operations. Operation 1 is being able to switch between any of the two existing characters, and the second operation is transforming every occurrence of one existing character into another existing character and doing the same with the other character. So that means that if you have 3 A's and 2 B's, you can turn these A's into B's and these B's into A's. And that has to be the same count on each side, if that's possible. So that means that they're swappable on that point. We can use the number operations of either strings as many times as possible. This is how we can determine it's close. If we're able to do operations 1 and 2 to a point where you can turn that string into another string. So this means that not necessarily every single count or frequency of a letter in a given word will not be the same as the other string. So we have to just determine if this is possible. So you don't have to actually go through, I think for this problem it's important to understand that you don't have to actually go through each operation step. You just need to determine whether these are actually feasible. So one thing we can actually to actually get the solution out of this is we can say that so we know that every single letter, we can agree that every single letter in word 1 has to be in word 2 in order to make that close words operation possible, because we have to be able to swap between any characters. We have to be able to transform to any of those characters. So we have to at least say that if we grab every distinct character out of word 1 and word 2, they should be equal. So that is a condition that we must account for in our code. Another thing too is we want to take the frequencies of every single letter in word 1 and word 2. So if we take a look at word 1 and word 2, right, we have a count of C would be 1 in word 1, A would be 2, B would be 3. In word 2, A would be 1, B, so we can write it out as C equals 1. So this is in word 1. C is equal to 1, A is equal to 2, B is equal to 3. Word 2, we can say C is equal to 3, A is equal to 1, and B is equal to 2. Okay, so these are kind of just in opposite order essentially. So I mean, in that case, if that's possible, that means that we are able, if we go through some number of operations or whatever, we should be able to swap between all of these, because we can transform every occurrence into another character. And I think that's all. No, we do one operation of just swapping between two existing characters, and then we're able to transform occurrences of an entire set of a given character set into another existing character. And you don't even need to have the same count. So this means that you don't need the exact same count, but you just need to ensure that those two counts are represented for when you're mapping this out. So we have our mappings out right here, right? So essentially what we can say, we can conclude from this, and I know it wasn't a definitive proof, but this kind of goes to show that if you checked, essentially, if you were to sort these two values out, you just have to check that if the two value sets that you get from the two words are equal to each other, then that means that it is possible to apply all the operations in order to obtain those two strings to be considered close by our definition here. You can't do a sum because technically, if you played around with this number set, you would it would break some of the cases. Say that if I added another A or something like that instead of, so say I got rid of this B, it's actually 1, and then I had 3 of this 2, yeah. So the sum would still be 5, right? Yeah, 5. This is x, so I don't know what I'm doing actually. Oh, I think I'm just counting one. Yeah, 3. So then this would be, oh, so like say that we had 3, 2 instead. I guess we should make it so it's not possible. So say we had like 4 A's, right? We had two, like 1 C and 1 B. We sum that together from word 1 and word 2. That's still like 6, but those values are not be able to transform to each other because you can't transform 4 A's into like distinct or like any of these characters here. You have to transform the entire character set or swap to existing characters. And we can show that here. Like if we were to have, so like I said that if you had like CAAB and you had CCCABB, like this is not possible, is what I'm trying to get at here. Okay, so let's just, we have that case right here. That should be false. And we'll write this code out. So we'll say that we said earlier that if the set of word 1 is not equal to the set of word 2, that means that if we were to grab all the distinct values out of word 1 and word 2, if they're not equal to each other, then that means that we can return false because we need to have all those characters. Like we need to be able to swap between the characters in each string. Now we're gonna create 2 dictionaries. I'm gonna use a default dictionary because I don't have to like instantiate a given key to its value every single time. So that means that I don't have to check like, oh, does that actually exist in the dictionary yet? It'll instantiate it by itself. So then we can iterate through all of the letters in word 1, and we can just add it into this dictionary, into its relevant dictionary. We can just increase the count there. We'll do the same for word 2. And then what we can do here is we can literally just return to see if we sort all of the values in the first dictionary, check it between the second dictionary. Are we able to see all those values that we had earlier that we showed? So is it for like example 3 is going to be 1 2 3 1 2 3. It should be, and that means that it's true because we're able to, if we're able to at least swap between all like the characters and whatnot, and they have like the same counts, we're able to perform these 2 operations like we said. And yeah, this one should be false like we said because there's no way that you can transform 4 A's into anything of word 2 to make this. So basically we just want to be able to make word 2 from word 1 using these 2 operations, and if you go through the steps we're not able to do so. So yeah, that's how you solve this problem.